Hi class, in this video we're going to be talking about our third exponent rule, and this one is called zero exponents. Basically what it means is any number with an exponent of 0 is going to equal to 1. So any base or number, so let's say a is my base, if it has an exponent of 0, it's going to equal to 1. So here's my example here. If I have negative 10 and that's my base, and it's to the exponent of 0, my answer is simply going to be 1. And now I'm going to do a quick proof for you guys. So in this proof, 2 to the power of 1, 2 to the exponent of 1 just basically means 2 times itself, how many times my exponent is. In this case, it's just 1, so I simply just have 2. 2 to the exponent of 2 basically means that the exponent tells me how many times I multiply 2 by itself. So in this case, this would be 2 times 2, so I'm simply going to get 4. 2 to the exponent of 3 tells me I have to multiply 2 by itself 3 times. So I have 2 times 2 times 2, which is going to be 8. And now 2 to the exponent of 4 tells me I have to multiply 2 by itself 4 times. So 2 times 2 times 2 times 2, that's going to be 16. Now, I'm going to ask you guys a question here. Is there a way for me to get from 16 to 8 by dividing by a certain number? So what can I divide 16 by in order for it to become 8? So the answer would be 2. If I divide 16 by 2, I get 8. Okay. And now let me ask this other question. What number could I divide 8 by for it to become 4? And the answer is 2. So notice the pattern here. I'm just going to keep dividing by 2. Let's look for my other case here. If I divide 4 by 2, would I get 2? Yes. Okay. So the pattern is still consistent. If I divide by 2, I get the next number, the previous number from before. So let's continue doing that. What is 2 divided by 2? It's just going to be 1. So basically, 2 to the exponent of 0 is going to be 1. So that kind of proves that if I change the 2 into something else, let's say I change it to 5, or I change it to negative 2, or if I change it to 1.7, any number still to the exponent of 0 is going to be 1, right? So I'm going to write that down. Any number to the exponent of 0 is equal to 1. Now we do have an exception though, right? So I have one exception. My one exception is 0 to the power of 0. 0 to the exponent of 0. If I have 0 as my base and the exponent is 0, I'm simply going to equal 0. That's the only exception. So everything else, though, is fair game. So example, if I had negative 5 to the exponent of 0, I'm going to get 1. If I had 1.6 to the exponent of 0, I'm going to get 1. If I had 98 to the exponent of 0, I'm going to get 1. So any base or number to the exponent of 0 would be 1, except for 0 to the exponent of 0, which would equal to 0. Okay, so now let's go over some examples here. I have negative on the outside, and inside I have 5 to the power of 0. So my base is actually going to be 5. So first things first, that negative is actually an invisible negative 1. And then I have 5 to the exponent of 0. Well, if we solve with order of operations, I want to solve for brackets first. There's nothing inside my brackets that I can possibly simplify anymore. So now I'm going to focus on my exponents. Let's solve for the exponents next. So in this case, 5 to the exponent of 0 is going to be 1. So now all I'm left with is negative 1 times 1. And a negative times a positive would still be a negative. So in this case, negative 1 times 1 is going to be negative 1. Okay, great. Now I have negative 5 to the power of 0. So my base is negative 5. So in this case, any number or base to the exponent of 0 except for 0 would equal to 1. So my answer is just 1. Okay, here I have a negative, invisible negative 1 on the outside. On the inside, I'm going to have negative 5 to the exponent of 0. In this case here, because the 0 is inside of the brackets and not outside, I'm going to end up having an invisible negative 1 here first. Then I'm going to have my 5 to the power of 0. So to solve this one, let's use order of operations. I have to solve what's in the brackets first. So inside of the brackets here, I have a multiplication between negative 1 and 5 to the exponent of 0, but I have to simplify my exponents first because that's next for BEDMAS, right? So if you recall, BEDMAS was brackets, exponents, division and multiplication, addition and subtraction, right? That's the order that we go in. So in this case here, I solve for the 5 to the exponent of 0 first. And 5 to the exponent of 0 is simply going to be 1. Great. So now I solve for the rest of my operation inside the brackets here. Negative 1 times 1 is simply going to be negative 1. So I get negative 1 left inside of those brackets. Now I have negative 1 times negative 1. Two negatives multiplied together gets a positive. So my final answer should become a positive number. Okay. Now, the last one here, I got an invisible negative on the outside, and on the inside, I have a base of negative 5. Now, because the zero's on the outside, I simply just apply my rule. Any base to the exponent of 0 is going to be 1. So in this case, I'm simply going to have negative 5 to the exponent of 0 be equal to 1. So now I just have negative 1 times 1 left, which would give me an answer of negative 1. And those are my examples for our third rule, the 0 exponents.